Hey everyone, I'm Leo, and over the past few weeks, I've been building a wearable that takes muscle activity from my forearm and turns it into a control signal. And then I built a video game to see how well it works. Currently, a large amount of research has been focused on how we interact with our devices and how to make it more natural. Specifically, how we can use our gestures and natural human movement to control electronics. For this build, I landed on a method called force myography. Force myography, or FMG, differs from the more standardly known EMG, or electromyography, in the fact that it measures mechanical displacement of the muscle belly versus measuring direct electrical signals. Alright, so unfortunately I didn't get any video footage of the actual assembly and design of the band, but here's our final version. We have a battery on top for wireless use. We're using a XIAO ESP32 board right here, and that is going to actually interpret all the information and house the data collection. On the bottom of this PCB, I left room for us to put that force sensitive resistor. Now you'll notice you can't exactly see it. There's something covering it. That is going to be a very pivotal part of this project. So if I just go ahead and take that off real quick here, as you can see underneath, I got the force sensitive resistor. Now, the reason for this PLA disc right here. It's a very simple solution to what I believe is a difficult problem. When I first actually ran tests, I was not getting any data. And that's because at the time, the sensor was completely flush with the band, meaning that when I contracted my arm, you would have no difference between the muscle pushing against the band and pushing against the resistor. What you need is a concentrator of sorts, and that is what I designed here. Now, there are multiple ways this can be done, but what I believed is that since the muscle belly is already going to be soft and malleable, that some sort of solid protrusion into the muscle belly is going to concentrate the force of the displacing muscle onto the sensor itself, versus if you have it completely flat, it won't. This turned out to be the key to getting my project to work. And now we only have one force sensitive resistor, but I think we're actually able to get pretty high fidelity when it comes to the level to which my forearm is flexing and squeezing. More sensors can be used in a future version, which could allow us to potentially get signals from different muscles on the forearm. However, right now, on the extensor muscle belly, when you actually flex the forearm, there's this mechanical displacement that causes a lot of shifting of the muscle mass right on that extensor area. So that is why I decided to put the sensor right there. And so then I moved on to the next phase, which was actually taking this band and using it to control something meaningful. Some sort of output that actually is going to do something or affect some sort of change. To this end, I came up with a game called Crashy Rocket. It's like a Geometry Dash / Flappy Bird style video game that I was able to create that takes the input from the band and is going to control the thrust on the rocket's propulsion. The super cool thing about this is, unlike standard input from a keyboard or mouse, you have levels to how hard you squeeze or press on the throttle. This means that a harder squeeze is going to increase the velocity more than a smaller squeeze. So the magnitudes are going to associate with how fast the direction changes. And so there it is, and it actually works pretty well. So for future versions of this device, like I mentioned, I definitely plan on going and putting different resistors in different areas so that I can go ahead and interpret different muscle signals, whether the hand is flexing or extending, not just net change in muscle belly displacement. However, I think this is a great first attempt at this type of technology, and it works surprisingly well. There's a lot that I can still do with this. Anything that needs to be turned on and off or have some sort of varied one-dimensional control can be done with this device. This has applications in robotics, that is opening and closing a robotic hand to a certain degree. Even in the rehabilitation setting, there is some application when it comes to how those with neuromuscular injuries to the wrist and forearm or even other parts of the body have to train to get back that submaximal control and extended holding of muscle flexing. A device like this is going to allow for individuals like that to have a good way, a fun way to train that type of movement and actually get impact on their rehabilitation and feedback on how well their muscular output is doing in real time. So thank you so much for watching. This has been a really fun project to build, and I'm hoping to iterate on it more in the future.